Hello, hello, hello. Welcome back to my next live stream. So this is the third live stream where I'll be continuing going through the F35 accident report in preparation for my our workshop, our discussion next week, next Friday. So if you'd like to come along and hear and talk and contribute to a discussion about Stamp STPA cast and this particular F35 accident, it'd be great to see you. The link is below. So what I'm going to do now is I'm going to pick up from where I left off this morning, and then we'll continue for about an hour. I don't want to go too much longer than an hour because the online MIT stamp workshop is starting in about an hour. So I don't want to clash with that. And we'll see how far we get. Hopefully we can finish it. If not, I'll jump on again probably tomorrow, and I'll let you know the arrangements, the times on LinkedIn. So let's get stuck in. Okay, let's see if anybody is here. Yeah, so of course, just to remind you, there is a bit of a feedback delay of about a minute between you typing stuff in the comments on LinkedIn, them appearing on the screen, and then for me to be able to respond. So don't expect an immediate response, but please, contribute. If you've got anything interesting to say or some context or expertise to add, please don't hesitate. Right, so let's have a look then. Large screen. So where we left off earlier on, so let's just jump out. So we spoke about, where is it? Highlighter pen. So we got through all of the airframe, missile or space vehicle systems aspects. We went through the weather, talked about crew qualifications, medical stuff, and we got to operations. So that's where we're going to continue. So we've got about 26, less than 10 pages to go. So we'll see where we end up. Great. And if you wouldn't mind, if you want to stick in the chat whether you can hear me or not, because I'm always, like I said this morning, I'm always paranoid that I could be talking away. I'm unmuted, but worried that you can't hear me. So yeah, if you wouldn't mind just typing in the chat, let me know you can hear me. So let's have a look. So we talked about all of that. So yes, we've got 1, 2, 3, 4, 5, 6, 7 pages to go. So we should be able to get through this pretty quick if I don't talk too much. Here we go. So let's put this to one side so you can see the control loop that we started working on earlier on. So let's have a look. Operations and supervision then. So the only applicable special interest item, in regards to the mishap sortie was cold weather operations. This special interest item must be briefed during every flight briefing and consisted of briefing topics such as cold weather, AFE gear, hangar bay operations, ice, foreign object debris, altitude corrections, taxi speeds, runway condition readings, braking effectiveness, rapidly changing weather conditions, snow removal, etc. Supervision. A review of the flight training records for the mishap pilot and the other flight members showed that all were current and qualified to participate in the sortie. Human factors analysis. The Accident Investigation Board considered all human factors relevant to this mishap as described in the DoD Human Factors Analysis and Classification System HFACS number 8. The HFACS number 8 is a framework that identifies potential areas of assessment during an accident investigation and lists potential human factors that play a role in an aircraft mishap. Fantastic. I wonder if the Department of Defense has an equivalent to this for applying STPA or cast accident analysis. And if they don't, I'd recommend it. And if you need some help with that, get in touch. So let's just mark that off. Why isn't my pen working? There we go. It'd help if I turned Bluetooth on, wouldn't it? Right. There we go. STPA or cast equivalent. If not, why not? Because I'm hoping after you've watched these videos, you'll be like, oh, wow, Si, this is amazing. We really need this in our organisation. Can you come and give us a hand? There's the offer. There's the opportunity. Okay, so a human factor is any environmental, technological, physiological, psychological, psychosocial, psychobehavioral factor a human experiences that contributes to or influences performance during a task. The framework is divided into four main categories. So we've got acts, preconditions, supervision, and organisational influences. So from what you've seen so far from this live stream and the previous two that I've done, and thinking about the concept of a control loop, I hope you're starting to realise that HFACS doesn't go as far as STPA does. And I'm not saying that we shouldn't do HFACS. I'm just saying that enriching STPA with the results from HFACS will be beneficial, but likewise using STPA or CAST to decide where to apply HFACS. So I'm anticipating in the next section, with fingers crossed, that the investigation report actually looks at the HFACS, human factors aspects of the people involved in maintenance and the people involved in managing the hydraulics drums and the pumps and the records and everything else. Perhaps even those involved in deciding not to have what was the technical term? Let's just go back to the diagram. The Hazard Comms Support Program Manager. Why didn't they exist? Why did it make sense to the humans involved in that for that not to exist? So yeah, acts. Yeah, let's just jump over here. So from a controller perspective, when we're talking about actions, in fact, let me just get a clean one of these because I need a clean one, not a really dirty one like that. So let's just get rid of all of that. Delete. There we go. Nice clean one, everybody. So when we're thinking about acts, in terms of STPA or CAST, we're talking about control actions, this bit. Oh, there we go. Green pen on there as well. So acts, when we're talking about preconditions, that's covered in many different places in the concept of a control loop and a control structure. So that could be, things that affect decision making, influences beliefs, which is related to feedback. Could be the behavior of the control process. It could be inputs or outputs of the control process. It could be influences directly on the controller, perhaps other inputs or outputs, such as physical environmental conditions or the psychological safety in the organisation. What about inputs and outputs from the layers above in the control structure? So how could all of those contribute and conspire to the human doing things that are potentially unsafe? Supervision, so again, that would be your controller above. What's going on there? Is there enough or adequate supervision? In terms of preconditions, I've just spoken about that. In terms of organisational influences, so that is a combination of not just other controllers in the structure, but perhaps other elements, other aspects in the control structure that are not immediately obvious. Because as I say, when you model a control structure, you can model direct causes, direct influence on the actual control process down the bottom, but also you can model other elements that are more indirect and perhaps are not even directly related to the operations control structure, but are actually related to the design control structure, the development organisation control structure. So yeah, let's keep moving. So each category is subdivided further into related human factors subcategories. The main categories allow for complete analysis of all levels of human error and demonstrate how such errors may interact together to contribute to a mishap. The human factors relevant to this mishap are defined below. All right, before we jump into that, I just want to highlight this bit here. So the main categories allow for complete analysis of all levels of human error and demonstrate how such errors may interact together to contribute to a mishap. I'm hoping you're starting to realise that HFACS, acts, preconditions, supervision, and organisational factors is a very broad analysis of the situation that's gone on. Whereas if you use a control structure and look at it through the lens of these jigsaw pieces, these control loops, you can find far, far more things than HVACs can. That's in my opinion. I'm happy to be challenged on that, and I'm happy to do a competition if you want to see. If you want to see whether it really is more advanced than HVACs and bow ties and a lot of the others, then let's have a competition. Challenge me. Let's do it. Okay, so applicable human factors then. So ineffective team resource management, fantastic, is when crew team members fail to actively maintain an accurate and shared understanding of the evolving task or manage their distribution of tasks, which resulted in a hazardous condition or unsafe act. If you recall from my first live stream on this topic, I introduced the concept of contributory control actions in the context of an accident investigation when we do a cast analysis, instead of, as opposed to, unsafe control actions in the context of an STPA hazard analysis before an accident has occurred. So I don't think it's appropriate to refer to these actions as unsafe actions for the various reasons I explained before. But anyway, this includes communication breakdowns. So yeah, that's in fact, actually, let's just zoom. Let's get our structure analysis list out. So communication breakdowns, so there we go, communication breakdown, so interactions or changes over time, evolution. Standardized terms, phrases, hand signals or language execution barriers. So that particular topic is actually quite relevant to when they were having the conference call. So if you remember the conference hotel, this thing on the left-hand side, and this interaction between the supervisor of flying and the conference hotel, and then back again, you could argue that that's related to this. There should have been standard phraseology for that, as far as they could within reason. That's something to consider for the future, by the way. Critical information not shared, rank position intimidation. Oh, that's interesting. That wasn't explicitly discussed, but that is certainly something for consideration. Lack of assertiveness or other teamwork functions. Okay, so this is good, but it is quite superficial. There is a lot more that could be dug out using STPA or CAST. SI001, ineffective supervisory or command oversight. Yep, I agree with that, certainly. Is when the availability, competency, quality or timeliness of supervisor leader oversight did not meet task or mission demands, which resulted in hazardous conditions or unsafe acts. Examples include failure to verify accuracy and completeness of work. Yeah, I think that's inadequate feedback. Conduct pre-combat checks, pre-mission inspections, mismanagement of emerging risks during mission execution. SI007, failed to identify or correct hazardous practices, conditions or guidance, is when any supervisor leader in the unit failed to identify or correct known hazardous conditions of equipment, facilities or written procedures or guidance, or correct unsafe work practice of personnel within his or her scope, which resulted in hazardous conditions or unsafe acts. Okay, I mean, yeah, they're kind of three broad aspects, but I think there's a lot more we can dig out by exploring the control structure a bit further, a bit more deeply. Governing directives and publications. Publicly available guidance relevant to the mishap. So we've got AFI, yeah, okay. Aircrew Standardization and Evaluation Program. Human Factors Analysis Classification, so that's version 7. I thought they were talking about version 8. Thought it said version 8. Number 7. Okay, don't know why that is. Is that finger trouble? Is that an unsafe act? Pressing 8 instead of 7? I don't know. DAFMAN, Air Force Occupational Safety, Fire and Health Standards. Okay, great. Notice, all Air Force directives and publications listed above are available digitally on the Air Force Department Publishing Office. Great. Okay, just an observation. You remember what I said earlier on about the safety information system? So that's sort of a very formal sounding label. This website and the information on it could be considered part of that safety information system, perhaps informally. So if it's wrong or unavailable or incorrect, the version control is not very good, then that could contribute to accidents, perhaps in a small shape or form. Other guidance relevant to the mishap. So let's have a look. So we've got SAE, Society of Automotive Engineer, hydraulic cleanliness standards, the maintenance newsletter, which I mentioned earlier on from their look. So aircraft designer, manufacturer, aircraft maintenance newsletter. Then we've got the flight manual, which I mentioned over here. There we go, flight manual. And then in-flight guide. Can't remember what that was. Don't know. Known deviation from directives or publications. The Air Force Occupational Safety, Fire and Health Standards and related datasheet standards for hydraulic fluid storage, which was part of a substantially contributing... Okay, so let's have a look then. So that is the maintainer's control structure. So let's go down here. Is that an Air Force regulation, AFI? I can't remember. What does it say, AFI? Yeah. So whatever this AFI is, I think it's under Air Force regulations, that one there. So the question is, it says known deviation from that publication or procedure. Well, why? Why is that? We need to be exploring and answering these questions. Why did that not find its way all the way down there? Why was there no feedback? Did it find its way to there? Did that influence this? We don't know. That's not really covered. So yeah, so that's the bulk of the investigation report. We're now going to move on to the last part, the statement of opinion. So let's just mark that off. We've done that. We're now on the home stretch, last 4 pages, everybody. Let's keep pushing. Let's keep going. Where are we? So last few pages. Here we go. Right. So statement of opinion. Oh yeah. Before I keep banging on, me reading this report, I'm not critiquing the individuals involved in the accident or the people involved in the investigation and writing this report. I don't want to come across as critiquing them and finding things that are bad. The purpose of this discussion and this review is essentially just to understand and demonstrate how you could use STPA or CAST analysis to some extent. What sort of things could you look for? What sort of questions could you generate over and above an official investigation? And to learn from that and to go further. I want to be humble. I hope that people watching this are humble and sort of recognise I'm not trying to critique them or point fingers at them. I'm just trying to help move general practice along and get more people involved and interested in using STAMP, STPA and CAST. Because I firmly believe and have had experience where this can fundamentally help and improve and supercharge your investigations and your system safety assessments. And I'm on a personal mission to support that. So please, whatever I say that comes from this, take it from a place of respect, appreciation, and that I want to help. I want to genuinely make a positive difference. And if you need that help and support, please don't hesitate to get in touch, and we can sort out how we can possibly do that. Okay, so with that said, let's just have a quick drink. And let's get back on with it. So, statement of opinion. Statement of opinion. So, under 10 U.S.C. 225 Delta, the opinion of the accident investigator as to the cause of or the factors contributing to the accident set forth in the accident investigation report, if any, may not be considered as evidence in any civil or criminal proceeding arising from the accident, nor may such information be considered an admission of liability of the United States or by any person referred to in these conclusions or statements. Fantastic. That is so important for safety and continued learning. It is so important to be able to do this. On the 28th of February, at approximately 12:49 local, the mishap aircraft, an F35A, crashed after completing a touch-and-go landing at Elson Air Force Base. The mishap aircraft was operated out of Elson Air Force Base by 355 Fighter Squadron and assigned to the 354 Fighter Wing. There were fortunately no fatalities. The mishap pilot assigned to 354 Fighter Wing ejected safely before impact. He sustained minor non-life-threatening injuries. The mishap aircraft was destroyed upon impact with a total loss valued of $196,500,000. The mishap aircraft debris was contained within airfield boundaries at Elson Air Force Base. Just a quick point there. So when we're doing a cast when we're doing cast or STPA, one of the things we do as part of the foundation phase is we identify the losses involved and the hazards involved in this particular accident. Now, in this case, we've got human injury. Could have been worse than that, but human injury. We've got financial losses. We've got mission losses. But in terms of aircraft loss, we've destroyed the aircraft. We've damaged the aircraft. But what about other things such as environmental contamination with exotic materials and the cost associated with cleaning that up? Obviously I don't know the details and I'm not going to, postulate anything like that. But when we're thinking about the concept of losses and hazards, we have to be quite broad in what we're thinking about. And yes, this is a safety investigation, so I'm preaching to the choir. But when we're thinking about losses and hazards, it's important to expand our focus to, well, what are the other losses and hazards or potential near miss, what could have got worse in this situation? And also it helps us to identify, when we talk about hazards, it helps us to identify the starting point for some of the control structure elements. So, when we're talking about a particular hazard, logically there's going to be some high-level safety constraints associated with that. And by extension, there's going to be a control structure of some description enforcing those high-level safety constraints. So if we first think about the losses and hazards involved, that can give us a starting point as to where we should consider starting our control structure model. Now, I've specifically not done that in this case, on the live stream, because we're going to talk about that in some detail next Friday. So if you haven't already registered, please register below. And of course, if there's anybody that a friend or colleague that will benefit from this or benefit from providing some critical feedback to me, please invite them along and let's talk about it. Okay, so the mishap aircraft was flying as the third ship in a flight of 4. After initial takeoff, the main mishap aircraft's nose landing gear did not retract properly, and this was due to hydraulic fluid contamination by water that froze, preventing full strut extension and resulting in the nose landing gear being canted to the left. After running initial checks, the nose landing gear was still turned approximately 17 degrees to the left. The mishap pilot initiated a conference call. Was it the mishap pilot that initiated the conference call, or was it the senior SOF, supervisor of flying? I didn't think the mishap pilot had directly spoken to the conference hotel people. Maybe that's just my understanding, or maybe it's not clear in the investigation report, but I didn't think the mishap pilot had directly talked to them. But anyway, maybe I'm being a bit pedantic. The mishap aircraft held for approximately 50 minutes while the team developed a plan of action. The mishap pilot accomplished 2 touch-and-go landings, attempting to recenter the nose landing gear wheel. While both attempts failed to center the nose landing gear wheel, the right main landing gear strut and the left main landing gear strut did not fully extend. So both of those didn't extend. After takeoff, due to ice forming inside the strut. After the second touch and go, all valid weight on wheels sensors indicated the mishap aircraft was on the ground, and the mishap aircraft transitioned to the on-ground flight control law automated ground operation mode, causing the mishap aircraft to operate as though it was on the ground. However, because the mishap aircraft was actually airborne, it was uncontrollable. The pilot successfully ejected and emergency procedures were at the scene within a minute. Right, just before we move on, there's something else that's just occurred to me. So if we're talking about so this controller here is the mishap pilot. This controller here is the mishap aircraft. I've revised the control structure and added a couple of levels of detail. So this is now the mishap aircraft here, and I'll tidy the diagram up. This is the flight control system with the 5 weight on wheels sensor input to here. And then we've got the flight control system providing controls to the flight controls, control actions to the flight control, to the aircraft, to cause it to behave strange due to the control law being on ground and the process model being the aircraft is on ground. So just before we jump on and I forget about it, if we're thinking about improvements to the design of the aircraft or digging further into the design of the aircraft, and I want to be cautious that I don't want to discuss too much detail for this because obviously it's a defense system. But if we were designing this control algorithm and its decision to switch to the on-ground control law was based on weight of wheels inputs, wow signals, wouldn't it be appropriate to consider perhaps other feedback? What other feedback? And let me use my pen. It's easier to use. Let me use my pen. It's not that one. It's this one. There we go. Let's zoom out a little bit. In fact, let's make it full screen so it's a bit easier to see. So here's the aircraft. There's the weight on wheels sensors. There's the flight control system and its control algorithms and making decisions. If we were thinking about how to improve the design or to investigate further and stop this from happening again, if the algorithm, and I'm assuming here, because there's no detail, but let's assume for a minute, the design of those flight control laws is that upon receiving 3 out of 5 wow signals, and presuming there is a sense or range check of some description, believe the aircraft is on the ground and act accordingly. What other inputs, what other feedback do you think that control algorithm would benefit from to help it decide whether it's on the ground or not? Let's say, for argument's sake, airspeed. So if the airspeed increases to a speed that obviously it's never going to have on the ground, or altimeter information, if you knew you took off from an airfield at a particular airfield elevation, and you're returning to the same airfield, wouldn't it be prudent to know that you're off the ground using altitude information? Does that mean there's potentially a radar altimeter feedback that could be used? Maybe. I'm guessing. I don't know. Maybe it doesn't have radalts like commercial aircraft do for various military reasons. What about G loading? You know, if you're experiencing G loading that signifies that you're flying as opposed to on the ground, is that a relevant piece of feedback? I'm just making suggestions here. I mean, the safety engineers, you know, if you're watching this, have a look at your fault tree analysis. You know, what is the logic behind these controllers? What are the inputs? What are the state machines? You know, are these sensory feedback available? Is it even appropriate to use this sensory feedback? Maybe they'd already done the analysis and said, we can't use these pieces of feedback. We can only rely on wow signals because of various valid reasons. Or maybe it's a design flaw. I don't know. You know, you can't tell me because obviously it's classified, but I'm hoping that I'm giving you some food for thought. That's all I'm saying. Let's move that to one side. Now that we've fixed the flight control system on an F35, you know, please send a check in the post or let me know where I can send an invoice. There we go. Automate a ground operation mode, causing the mishap aircraft to operate as though it was on the ground. However, because the mishap aircraft was actually airborne, it was uncontrollable. The pilot successfully ejected and emergency responders were at the scene within a minute. In forming my opinion, I relied on the ALICE, Crash Survivable Memory Unit, the MP, Mishap Pilots and Mishap Wingman's helmet-mounted display, and panoramic cockpit display recordings, the targeting forward-looking infrared video, analysis and reports from the AFRL, the Lockheed Martin technical report on the accident. I'd be keen to see that. If send me an NDA to sign, I will sign it, and I will quite happily, gladly critique that using this method and show you what we can find. And interviews to reach an evidence-based causal conclusion. So number one, the cause. Let's just have a drink before we jump into that. Actually, are there any questions? For those that are watching, please stick some questions in the box or comments. Let us know what you think, whether this is valuable to you. Right, let's crack on then. So let's have a look. Number one, the cause. I find by a preponderance of evidence that hydraulic fluid contaminated by water in the mishap aircraft's landing gear struts, combined with slightly extended ground operations at extreme cold temperatures, caused ice to form inside the struts. Initially, the water in the nose landing gear strut froze, which started the cascading events. When the nose landing gear strut would not fully extend due to the ice in the strut, then the uplock hook was not able to engage the forward uplock roller. This caused both the initial unsafe gear indication and the nose landing gear to be canted approximately 17 degrees to the left. Because the PCL directed that was the pilot checklist, is it? PCL procedures, pilot checklist procedures, PCL. Directed the mishap pilot to put the gear down after first touch and go. Enough ice had formed in the right main landing gear strut to prevent it from fully extending, causing the right main landing gear weight on wheel sensors to declare it was on the ground. After the second touch and go, enough ice had formed in the left main landing gear strut to prevent it from fully extending, causing the left main landing gear sensors to declare it was on the ground. Okay, so where is it? Yeah, this here. So let's just make that a bit bigger. So if the logic is you need 3 out of 5 wow signals, and you've now got main left and main right landing gear saying valid wow, there you go. That's the aircraft behaving as designed. It entered the ground mode. It's very interesting that I would like to see the fault trees for that, because it's more than fault trees, it's also the design of the flight control system. Why is the algorithm based on 3 out of 5 wow signals, and why didn't they identify the potential scenarios for the wow signals to be valid, to be true, under no failure conditions? Yeah. Anyway, right, let's move on. So once all the wow sensors agreed that the mishap aircraft was on the ground, the flight control laws declared the aircraft to be on the ground. According to LM, the aircraft is not controllable while airborne if the control law is on the ground. Right, excuse me a second. You'll recall from earlier on today this maintenance newsletter that came from the aircraft manufacturer. And that maintenance newsletter, if you recall, let's just jump back to it. Where was it? Maintenance letter, come on. Maintenance letter, flight control law. Where is it? I know what I'll do. I'll search for it in there. It'll be quicker. Newsletter, there we go. So that is just before weather, which is here. So this one here. So this maintenance newsletter, here we go. So that maintenance newsletter said on a future flight which can cause erratic flying qualities. Right, so at no point, well, hang on, let me qualify this. So from my perspective, post-accident with hindsight bias, to me at this time, and now after the accident, it's obvious that this is more than just erratic flying qualities. This is, serious situation. So I'm taking it that according to Lockheed Martin, the aircraft is not controllable. So that's catastrophic. That's game over. That's loss of the aircraft. So just going back to this. So the input to the flight control system, in my view, should not be, and I'm presuming that this is the case, I don't know because I can't see the technical detail, it's probably classified. But if the input to this process model, beliefs, and the control algorithm, the clause, is literally 3 out of 5 wow, to switch between a mode where the aircraft flies and a mode where it's going to go uncontrollable and crash, I'd like to think that that logic needs to change. And STPA can certainly help with that, because clearly fault tree analysis is not good enough for this. But being a bit, confrontational about it. And if you need help with that, let me know, because I can certainly help with this, having done similar on other systems. So much of this series of events was repeated on the other flight on the 6th of February with the other tail number, as illustrated by subsequent testing on that aircraft. With a significant amount of water in the nose landing gear and left main landing gear struts at below freezing ambient temperatures. The struts were not able to reach full extension. According to LM, if the MLG struts are not within a certain degree of full extensions, the WOW sensors will report the aircraft is on the ground. So this is a design issue, everybody. This is a design issue. The flight control system should not be designed to behave that way. Or at least the pilot should have the ability to override or revert to flying control, revert to the power and approach algorithm. They might have an override. He might not have known to use it. I don't know. That's not covered by the investigation. Maybe I'm being a bit unfair there. Due to a lack of accurate documentation, I cannot determine when the water was introduced into the mishap aircraft's landing gear struts. Through interviews, I determined that the hydraulic barrel used when deployed in Kadena was likely contaminated with water. I thought it said 2024. Anyway, substantially contributing factors. I find by preponderance of the evidence that the crew decision making, a lack of oversight of the hazardous materials program, and lack of adherence to maintenance procedures for hydraulic service equipment were substantially contributing factors. Okay, well, why? Why was that? Why was the lack of oversight? Why was there a lack of adherence to maintenance procedures? Why did it make sense for those people involved to behave the way they did? I'm not pointing fingers or trying to argue. I'm just saying, why is that? Why did it make sense? Okay, so crew decision making. The entire team involved in this mishap, the pilot, the wingman, the supervisor of flying, I think that's supposed to say, unless there's a bit of a subtle banter there. I don't want to postulate. It's finger trouble, I'm sure. Operations group leadership, air traffic controllers and LM engineers who participated in the conference hotel admirably dealt with a challenging situation that had not been seen in the F35 previously. They did absolutely fantastic given the circumstances. And I'm sure that it must be quite stressful hearing somebody on the other end of the phone who's clearly flying a $200 million fighter jet, and then all of a sudden there's an explosion, crazy. The mishap pilot, for me, that it's not been seen in the F-35 fleet previously, it was just a matter of time. It was literally a matter of time. For me, the technical issue here is the flight control system and the way it behaves when the switches, the sensors are not working properly. Sorry, when the sensors report that it's on the ground when it's actually not. And I'm kind of, I don't want to be too short, but that for me as a system safety engineer, that's where the effort should be focused, as well as sorting out, supply chain and logistics of hazardous materials. But this is a design issue for me personally. It shouldn't have gone out of control and crashed in the way that it did. Anyway, the mishap pilot used a variety of resources available to troubleshoot and attempt to safely recover the mishap aircraft. The mishap wingman showed initiative and superior problem-solving capabilities by his excellent and timely inputs and observations. Absolutely. That, without their eagle eyes, that could have been an aircraft rollover on the ground and death. And for that second aircraft that was also affected, they were very lucky. As evidenced by using the helmet-mounted display to accurate estimate how far off centre the NLG was canted. That's pretty cool. The SOF supervisor of flying, Lockheed Martin engineers and 354th OG leadership all assisted and provided their best advice and considered a variety of potential options to fix the nose landing gear. However, in this situation, the decision to advise the mishap pilot to accomplish touch and goes led to the mishap pilot's uncontrolled ejection. I'm not sure. What else were they supposed to do? Apart from ditch the aircraft in the sea if they're anywhere near the sea. I don't know. The aircraft has to land, whether it's a crash land. Well, actually, having said that, and I suppose it's hindsight bias talking, but can the aircraft be landed wheels up? And I'd like to assume it is designed that it can land wheels up. I don't know, this control law situation has left me a bit concerned. As demonstrated by the flight on the 6th of February, the mishap aircraft could have safely recovered. That's a big assertion. If the weight on wheel switches on the second aircraft had behaved in the same way as the first aircraft, that would have been the same loss. That's a systematic flaw. It would have been the same. And as well, if that second flight didn't happen, or was it a different airfield and they were investigating it separately, they wouldn't have been able to draw that conclusion. So I think that's a bit of a... I don't quite agree that that's appropriate. On the 6th of February, the pilot landed his aircraft with the nose landing gear initially 10 degrees left of centre that corrected to 5 degrees left of centre on touchdown. The pilot landed safely without even realising. Well, again, yeah. So I think that's a bit strong, I'll be honest. But anyway, on the second touch and go with the mishap aircraft on the 28th of January, the nose landing gear straightened out to 6 degrees left of centre, which, based on the evidence of the 6th of February flight, would have given the... Yeah, but he couldn't have known that, could he? He didn't have a time machine. I can't say I'm too happy about that. I think that's a bit much. Because it was only by chance, you could say, that the second aircraft was affected. Yeah, I wouldn't have included that in this investigation report. That kind of... It affects the credibility of the report, I think, including that. I think that's a bit much. When the mishap pilot relayed the HRCs, what are they, everybody? Can you remember? HRCs, what are they? I can't remember. And it's not in the list, is it? Yeah, it's missing from the list. Is it a checklist or something? I should remember this by now. Come on, Simon, what is it? HRC. Health reporting code, that's it. When the mishap pilot relayed the health reporting codes after the first touch and go, the conference hotel participants potentially could have referenced the Lockheed Martin maintenance circular from April 2024 that said these WOW sensors could lead to aircraft controllability issues. I asked this earlier on. Did they know that? Did they have that information available to them? There we go, look, that red arrow there. From the maintenance newsletter to the beliefs, decision-making of the conference hotel engineers. I don't know how big Lockheed Martin is. I don't know how the team is organised. But I would like to think that they have some kind of operational help desk that is available 24/7 to answer the phone and respond quickly. And the people as part of that team are, very experienced, very competent, and have quick access to all the available information so they can make rapid decisions. Back... What year is it? 2025. So 20 years ago, when I worked with Rolls-Royce in Derby in support of their large jet engines, they established a 24-hour ops centre that I was fortunate to be able to contribute to. And they literally had highly experienced people available on speed dial, and they had shifts, and they could immediately access any information that was available or necessary to them. and they were always kept up to date, up to speed, because that's what you would expect. And so I'd like to assume that the conference hotel, the control structure involved in that conference hotel, that will be a similar sort of high-performing team with lots of information available to them, and it won't be disparate. This feedback loop here that I've highlighted, that is absolutely critical. So it says there that had the conference hotel participants considered this potential outcome, could have referenced it. Well, we're not talking about coulds, we're talking about this accident. So if they could have done it, great. Why didn't they? Why did it make sense not to know that? Is it because they weren't aware? They didn't get the email? What was the reason for that? Had the conference hotel participants considered this potential outcome, they likely would have advised a planned full stop landing or a controlled ejection. You see, that's interesting. So I said a few minutes ago, can they not do a wheels up landing? It's either a full stop landing with the brakes or it's a controlled ejection. Can you not land with the wheels up? I don't know. Is that a risk? The aircraft will turn over? I don't know. This is really interesting. This conference hotel here, the control structure involved in that really needs to be looked at and explored. And there's clearly not enough information in here for me to actually start looking at that in detail. So if I was consulted to support this, I'd be going down there and having a look at it and seeing how it fits together. And again, it's not to try and find people to blame. It's trying to understand, well, what is the control structure involved in this? How does it fit together? How do the control actions and feedback and information flows move around there? But I find it hard to believe that that's the only two answers. And as well, it says there was a software engineer. Hang on a minute. I think I've just stumbled on something. Right. Let's just go. Where does it say conference hotel? There we go. Conference hotel, everybody. Right. So it says here, 5 LM engineers participated in the conference hotel. So a senior software engineer, a flight safety engineer, and 3 landing gear systems engineers. You've probably already got this where I'm going. Where is the flight control system engineer representative in this conference hotel? Is it in the realm of senior software engineer to know that if you get valid, believable but incorrect wow signals, that'll put it in a ground mode and lead to it being uncontrollable? I find it hard to believe that, well, in the case of the flight safety engineer, if that flight safety engineer is anybody like me with the experience I've got, they would know the safety assessment, the fault trees, the FMEAs, how it all fits together. They'd know the logic of the state machines for the flight control system. They'd know that it was 3 out of 5 weight of wheel signals. I'd argue that if you had somebody like that on the team in that conference, they could have, with hindsight, perhaps recognised the potential risk of getting faulty wow signals. So again, for me, there's a question there, recommendation there, about the makeup and conduct of that conference hotel and the competence of the people in there. There's the spread of competence. You need somebody who knows about flight control systems and the logic and the algorithms, because obviously controllability of the aircraft is quite important. But then I suppose they may have had mental models that were, it's just stuck landing gear. How can that possibly lead to catastrophic loss of the aircraft, and not recognise the link? And I, given the experience and background I've got across a lot of different systems in a lot of detail, very similar to this, maybe I'm being a bit unfair. I'm not saying I want it. Yeah. For me, that's one of the biggest recommendations there. Dig into the conference hotel and find out its suitability for making those kind of decisions, because that's a big contributor to this. But I think it's unfair to say, had they known, they might have done something a bit different. I think that's a bit unfair on them, to be fair. When the mishap pilot relayed the HRCs after the first touch and go, The conference hotel participants potentially could have referenced the maintenance circular. Why didn't they know that? Why was that feedback missing? That the WOW sensors could lead to aircraft controllability issues. Well, that, for me, the conference hotel should have in the future, have some flight control representatives in there. In fact, any conference hotel that you have should always have the full spectrum of people available to critique the aircraft, not just system-specific people. Because the decision to just have system-specific people potentially biases the definition of the problem and definition of a solution. And given there's not much time to do it, I don't know. Question for airbase operations: do they have an area where they can do controlled ejections for the future? Is there a hole in the ground that can go and dump these things while people eject? I don't know. Right, lack of adherence to maintenance procedures. The airmen in the 355th FGS hazmat program did not follow established procedures and technical orders for storing and handling hazardous materials. So let's just jump to the other control loop. So we're talking about this one and this one. Why did it make sense for them to behave that way? Specifically, they stored hydraulic barrels outside while deployed to Kadena and on at least one other temporary duty away from Elson. At both locations, the barrels were exposed to humid conditions and inclement weather. Further, at the home station 355 FGS personnel did not observe personnel while they were filling hydraulic carts for use. Okay, so that's missing feedback. Lock the hydraulic barrel when not servicing carts. Document when and how much hydraulic fluid was used. Nor appropriately dispose of a barrel certified as empty. Yeah, I mean that's interesting as well. Because of poor record keeping, it is unclear whether the barrel certified for disposal was the same barrel that was stored outside and exposed to inclement weather, but the barrel used to service the mishap aircraft was contaminated with significant amounts of water. There are significant lapses in the following procedures that indicate an overall lack of discipline. This lack of discipline, specifically a lack of documentation for the hydraulic barrel, was the key reason I could not identify when the water was introduced into the landing gear struts prior to the servicing. Okay. Lack of oversight of the 355th FGS Hazardous Materials Program. The flight and squadron leadership allowed the culture of the hazmat program to decline by frequently swapping airmen in the program, leading to a general inexperience and lack of knowledge of the program requirements, such as proper storage and use. Okay, so we're talking about this controller up here making decisions about staffing and responsibility. That needs looking at. There's obviously something not right there, either resources or personalities involved. Leadership is critical. As Jocko Willink said in his book, Leadership Strategies and Tactics, all problems are leadership problems. And, by extending that to the concept of STAMP, all problems are control structure problems. And so that should be looked at and explored specifically. What is going on there? Are there cultural issues? Are there, perhaps, interpersonal issues or a broader cultural issue that needs to be sorted out? I don't want to assume or presume, but could there be any toxic elements in there from a leadership or behaviours perspective? What else is going on? At the time of the accident, there was not a primary hazmat manager assigned. There we go. That's not good. Why is that? Which led to one of the airmen assigned as an alternative manager, to assume the duties of the primary manager by his own initiative. There we go, everybody. So if we're looking through the lens of CAST, what are the safety-related roles and responsibilities of a particular controller? Well, if there is no primary hazmat manager, those responsibilities are not getting fulfilled. And if you have somebody else as an alternative manager and they assume the duties with their own initiative, does that mean that they know what safety-related roles and responsibilities they should be performing? And if not, why is the layer above these people not making sure that those responsibilities are properly allocated? So there's even above this area, there's a big question there from a leadership perspective. Okay, while this airman's actions are commendable because he recognised the need, yeah, fantastic. Flight leadership failed in their duty to assign a primary program manager. Great. Why? Why is that? What's the control structure? In conclusion, okay, so number 4, we're right near the end, everybody, just on time, got 5 minutes. Conclusion, I find by a preponderance of the evidence, the cause of the mishap was water that froze in the nose landing gear and main landing gear struts. The ice prevented the struts from full extension that led the WOW sensors to declare the aircraft on the ground when it was airborne. I could not establish when the water was introduced into the landing gear struts. Additionally, I find by a preponderance of the evidence that the crew decision making, a lack of adherence to maintenance procedures for hydraulic surfacing equipment and a lack of oversight for the hazardous materials program were substantially contributing factors. Great. Index of tabs. Okay, so we're done there. In summary, I was anticipating a lot more detail on the design and behaviour of the aircraft. Yes, the hydraulics were, contaminated. Great, that's part of the investigation. We should go and look at why that is and make recommendations for that. But ultimately, contamination of hydraulic fluid is something that's likely to happen. That's part of operating a complex system. So the bigger question for me, the more valuable, the more expensive question is why does the flight control system allow the transition to ground mode while the aircraft is still in the air? Is there any kind of override the pilot can flip a switch, or select a dial on the dashboard that says ground to flight? So if there is a fault with the landing gear because it's been shot off or frozen or whatever, they can still control the aircraft. There's a lot more to it than this, and I do respect that it is a defence programme and they're not going to talk about the details of the design of the aircraft in a publicly available report. But I'm hoping you can see from what I've done over the last number of hours, last couple of days, that there is more to this. And STPA and CAST, with the concept of control loops and control structures, can unlock that. And once you're empowered with those superpowers, for want of a better description, you can find so many more causes of accidents and improve the design of your complex systems or the operations of your organisation. So yeah, I hope that was helpful. You're welcome to drop me a comment or send me a message on LinkedIn if you like this. And of course, please register for next week, next Friday, the 3rd of October. And I really look forward to seeing you all there. There's quite a few people now. It's getting exciting. But I have got some technical capabilities for Zoom, so I can entertain a lot more people than just being a little box in the corner with a PowerPoint. We can have some fun, get together and really get into the detail of this. But thank you very much for watching. And please like, share and subscribe, as all the good YouTubers say. And I'll see you on Friday next week. Take care. Bye-bye.